Niagara Falls is one of the most spectacular waterfalls in the world, and a flow rate that often exceeds 2,800 cubic meters per second. Roughly 10 million people visit the falls every year.
Most visitors see only water. They marvel at the roar, the mist, the endless plunge of Niagara Falls. But beneath that spectacle lies a forgotten world carved by ambition. Long before we electrified cities, engineers hollowed stone in secret. And as their tools struck deeper, they built something far greater than tunnels, an invisible empire waiting just beneath the surface. What they uncovered next changed the course of modern power forever. What we think we see. At the surface, Niagara Falls performs like a spectacle engineered by nature itself. Tourists lean over rails as mist rises into the sky, carried by the thunderous impact of more than 3,000 tons of water crashing down every second. It's hard to look away. But behind the iconic curtain of falling water lies something few ever realize. A vast hidden system that began not with government plans or global energy battles, but with quiet ambition and whispered intent. In the early 1800s, settlers on both sides of the Niagara River began to notice things that didn't match the landscape. Small trenches appeared, quickly filled again. Narrow grooves in the rock curved toward the river, then vanished underground. There were rumors of workers cutting channels under cover of darkness, and the dull rhythm of chisels and hammers echoing from beneath the soil. These weren't mines, they weren't sewers, they were experiments. Mill owners were the first to act. To them, the river wasn't just a wonder, it was untapped momentum. Water wheels could spin, timber could be milled, grain could be ground, but to harness the full force of the river, they had to go below the surface, where water could be directed, not just watched, carving power from stone. By the mid-19th century, the crude diversion scratched into rock had evolved into something far more deliberate. Mill operators, now confident that water could be guided with precision, began cutting deeper and wider. The earliest of these underground channels were built not as part of a coordinated plan, but as isolated adaptations, each mill carving its own shortcut to power. Workers followed instructions without understanding the full scope of what they were building. A tunnel here, a wheel pit there. Piece by piece, a subterranean network began to take shape beneath the surface. Conditions underground were brutal. Armed with hand tools and early blasting powders, laborers chipped away at uneven layers of limestone and shale. Air was thick and stagnant. Lanterns flickered against damp walls. One misjudged charge could flood a tunnel or bring it crashing down. Yet the work continued, because the rewards above ground were immediate: longer operating hours, faster production, and the promise of more profit. What made these efforts extraordinary was not just their physical toll, but their cumulative effect. As more mills sprang up and added tunnels of their own, the once fragmented passages began to intersect. Workers began using the tunnels to move between buildings without ever stepping outside. From above, nothing had changed, but below, Niagara was being transformed into a living machine. By the 1850s, the trickle of progress became a surge. In 1853, the Falls Hydraulic Power and Manufacturing Company launched a new phase of development, a formal hydraulic canal. This wasn't a crude diversion, it was a carved commitment to industrial power, feeding a growing underground infrastructure with carefully controlled force. Manual gates regulated flow, gradients were measured down to the inch, and every cut into the stone became part of a larger, invisible blueprint: Tesla, the Power War, and the Adams Tunnel. As the 19th century neared its end, Niagara Falls became ground zero for one of the most consequential rivalries in modern engineering: the war between Thomas Edison's direct current system and the emerging promise of alternating current, championed by Nikola Tesla and George Westinghouse. For decades, DC had dominated urban power, efficient at close range, but impractical for long-distance transmission. Tesla's AC, though elegant and scalable, remained largely unproven. What it needed was a stage. Niagara offered not only drama, but the perfect test: a river with unstoppable momentum and the hunger of two growing nations on either side. In 1893, Westinghouse was awarded the contract to electrify Niagara Falls using Tesla's alternating current design. It was an audacious leap, Beneath the Adams Power Plant number 1, engineers began carving an enormous tail race tunnel, over 18 feet high and nearly 7,000 feet long, cut directly through bedrock to return water from the turbines back into the river. Unlike earlier tunnels, this was not just functional, it was foundational. Its curved horseshoe profile stabilized surrounding rock under immense hydraulic pressure, allowing millions of gallons of water to flow silently beneath the city every day. The work was grueling. Crews blasted through shale and limestone, often advancing just a few feet per day. Timber supports were placed as the tunnel extended. Brick linings added where the rock grew unstable. Reports from the time described near constant fear of sudden cave-ins, of water breaking through soft layers, of miscalculated charges igniting chaos. But the urgency was unmatched. This was more than construction. It was a race against doubt, delay, and the weight of a national spotlight. On November 16, 1896, Niagara's current lit the streetlights of Buffalo, 26 miles away. The impact was immediate and global. Alternating current had triumphed, proving it could scale far beyond its generators. But beneath the headlines and celebrations, the real victory lay underground, inside a tunnel that no one on the surface could see, but that had quietly changed the course of energy, industry, and city planning around the world. Canada digs deeper. While American engineers were carving out the Adams tail race beneath Niagara Falls, their counterparts across the river in Ontario were watching closely. Canada understood that every drop diverted to the United States meant less momentum for its own ambitions. In response, the Ontario Power Company launched one of the boldest underground engineering feats in Canadian history, constructing a massive hydroelectric system beneath Horseshoe Falls, beginning in 1904. This wasn't merely a copy of what had already been done, it was an escalation. Rather than relying on a single excavation point, Canadian engineers coordinated multiple dig sites, boring into the earth simultaneously, from access shafts and river intake portals. The geology offered both help and hazard. The upper dolomite rock provided stability, but lower strata were soft, prone to collapse. Brick and concrete linings were applied with obsessive precision, layer by layer, to ensure these tunnels could withstand the immense force of water flowing through them. The centerpiece of the network was a main tunnel over 2,000 feet long, feeding 15 turbines via branching draft tubes. Massive steel gates allowed workers to control the water flow with accuracy rarely seen at the time. But perhaps most striking was who built it. Thousands of immigrant laborers, Italians, Poles, Hungarians, endured brutal shifts by lantern light, chiseling through stone and detonating explosives with nerve-wracking timing. Safety nets were few. Precision was everything. When the tunnels opened, power surged not only to Ontario's factories and streetcars, but into a rising national grid. Canada had secured its share of the river's strength. Beneath the thunder of the falls, another empire of water and stone had been born, one whose arteries still pulse in the dark beneath the city. The hidden lattice. As the 20th century advanced, the machinery of progress shifted gears. The underground tunnels that had once been arteries of industry gradually fell silent. Electric motors replaced water wheels. Factories modernized or closed entirely. And the complex network of tail races, conduits, and mill tunnels beneath Niagara, once humming with kinetic force, began to disappear from public consciousness. Many were sealed. Others were simply abandoned, left to flood or collapse beneath layers of sediment and time. Above ground, cities expanded. Warehouses, roads, and neighborhoods were built directly atop these forgotten corridors. To most people, the ground seemed solid, its story complete. But among older workers and locals, rumors persisted. Some spoke of strange echoes heard at night, of blocked stairways and old buildings that led downward and never reopened. There were tales of maintenance crews discovering rusted gears far below modern basements, of narrow shafts leading into darkness carved by unknown hands. Then, in 2018, a team of engineers and archaeologists conducted a detailed survey on both the American and Canadian sides of the falls. What began as a routine mapping project turned into a revelation. Beneath layers of rubble, they uncovered vast sections of the tunnel network that had never been documented. Massive brick-lined chambers still held rusted turbines in place. Piping systems, sluice gates, and maintenance tools, some untouched for nearly a century, sat frozen in eerie stillness. In some sections, the scale was staggering. Arches soared overhead, water-stained and cracked, while tighter crawl spaces hinted at emergency routes or improvised repairs. The rediscovered network was far more intricate than anyone had guessed. Multi-level, multi-directional, and far more interconnected. It wasn't just a collection of tunnels. It was an invisible infrastructure, a skeletal system designed to carry water, energy, and human ambition through the bedrock. The world above had forgotten, but the stone had remembered everything. The modern echo. While Niagara's older tunnels fell silent, a modern giant awoke beneath the surface. In 2005, engineers deployed one of the largest tunnel boring machines ever built, nicknamed Big Becky, to carve a new hydroelectric corridor beneath the falls. Over 6 years, she cut a 10.2-kilometer tunnel wide enough to fit a 4-story building, moving more than 500 cubic meters of water per second. Most visitors never know it exists. The tunnel silently feeds the Sir Adam Beck Power Station, sustaining a vast grid across Ontario. Where 19th century workers chiseled rock by hand, Big Becky did in years what once took decades, yet the goal remained the same, harnessing the roar from below. This tunnel isn't just infrastructure. It's a reminder that Niagara's story was never frozen in the past. It's still being written, in silence, in stone, and always just out of view. Beneath the roar of Niagara lies a legacy not of water, but of will. Tunnels forgotten by time still pulse with human ambition. If stories like this move you, subscribe for more hidden histories, because the deeper we dig, the more power we find beneath the surface.